Hello, today we are going to prove a theorem that alternate interior angles are congruent. And we are given a line L and a line M that are parallel lines, and we are also given a transversal T that cuts through both of those lines. And our alternate interior angles are circled in red, and we are supposed to prove that these two alternate interior angles are congruent. So here we have our diagram, and as you can see, I have yet another angle circled, and we'll get to that in a moment. And before we dive into our formal proof, we need a basic plan of action. So let's just first write down what was given to us. And what was given was that lines L and M are parallel, and line T is a transversal to lines L and M. Now, we also want to then write down what we want to prove. And we are trying to prove that angle 3 is congruent to angle 6. And we wrote that there. And now, as we look at our diagram, this is where we have to start to think of things that we know in the past. Let's try to recall a postulate or axiom that involves parallel lines and its angles. So we do have a postulate that states that corresponding angles are congruent. Well, what's a corresponding angle? Well, let's look at angle 6 here. Angle 6 is above line M and to the right of the transversal. Well, let's look up here at line M. What angle is above and to the right? Well, that's angle 2. So angle 2 and angle 6 are corresponding angles. And we have a postulate that states that those two angles are congruent. So now that we know that is true, if we could just prove if 6 is congruent to 2, if we could prove that 3 is also congruent to 2, then we can conclude that 3 is congruent to 6. So how would we do that? Well, we know that 3 and 2 are vertical angles. So all we would really have to do was prove that vertical angles are congruent. Then we could go ahead and apply our postulate that corresponding angles are congruent, and then we could conclude that all 3 are congruent to each other, so 3 is definitely congruent to 6. So let's go ahead and write our first part of our plan then. So the first thing we have to do is prove that 3 is congruent to 2. So basically we're proving that vertical angles are congruent. And then, after we've proven that, then we just state that angle 2 is congruent to angle 6 by using the postulate that corresponding angles are congruent. So once we've done these two things, we can say, well, since 3 is congruent to 2 and 2 is congruent to 6, then 3 is congruent to 6. So that's our plan. So, and you may think to yourself, well, we have a theorem that says vertical angles are congruent. But in this exercise today, we're rigorously proving this alternate interior theorem. We're not going to rely on any theorems previously learned or not learned. We're only going to rely on axioms and postulates. And remember, an axiom is a general statement that we all accept. It's a general statement about most most mathematical disciplines. And a postulate is a statement that we accept, but it only refers to geometry. So let's go ahead and start our proof. And as you can see, I have the diagram here, and I have yet another angle circled in green, and we'll get to that in a minute. And I have our plan here, and I have what was given. L is parallel to M with transversal T. So now what we have to do is we have to prove the first part of our plan, that angle 3 and angle 2 are congruent. So we have to use something in this diagram that they both share, that these two angles share, something they have in common. Well, they both share angle 1. They're both adjacent to angle 1. And they both create a line with angle 1. You could see angle 2 and angle 1 make a line, and angle 3 and angle 1 make a line. So angle 1 is the angle they have in common. So let's use that to our advantage. So let's just start with by stating their relationship. So we'll just say that angle 3 is supplementary to angle 1. Well, how do we know that? Well, by definition of supplementary angles. If the outer sides of adjacent angles, here's the outer side of this angle, and here's the outer side of angle 3. If the outer sides of adjacent angles form a straight line, which they do, then angles are supplementary. So now let's do the same thing with angle 2 and angle 1. Angle 2 and angle 1 are supplementary for the same reason. So now that we've defined their relationship, let's put some numbers to that relationship. So angle 3 and angle 1 are supplementary. Well, what does that mean? Well, that means that angle 3 plus angle 1 equal 180 degrees. And you can see they do. That's what a line is. How do we know that? Well, by definition of a supplementary angle. And then also angle 2 and angle 1 equal 180 degrees. And that's by definition of a supplementary angle. So now we have our equations. But now we have to try to manipulate these equations so that we isolate angle 3 in this one and isolate angle 2 in this one. Because that's what we're trying to prove, if you recall. We want to get 3 and 2 by themselves somehow so that we can conclude something from that relationship. So let's go ahead and work on this equation here, and let's try to get angle 3 by itself. And the way to do that is to just subtract angle 1 from both sides of the equation. So that's what we did. Angle 3 plus angle 1 minus angle 1, and we minused an angle 1 on this side. These angle 1's drop out, and we're left with angle 3 equals 180 minus 1. Now, how are we able to do this? I know we do it all the time and we take it for granted, but believe it or not, there's an axiom called the subtraction axiom that allows us to do this. And that axiom states that if equals, this says equals, that's an S. If equals, and the equals here are the angle 1 and angle 1. If equals are subtracted from equals, so if these equals, the angle 1, are subtracted from this equal statement, then the differences, which is angle 3 on this side is the difference, and this is the difference on that side, so these differences are equal. So that's just something we always take for granted, but this is why we can state that. So now we have angle 3 by itself equaling this expression. And let's do the same thing for angle 2. So we're going to add a negative, or I should just say subtract, angle 1 from both sides of this equation to isolate angle 2. And we come up with angle 2 plus angle 1 minus angle 1 leaves us just with angle 2. And the same thing on the other side, then we're just subtracting an angle 1 and it leaves us with this statement. So now we can see that we've isolated angle 3 and angle 2, and look at this, they both equal the same thing. So if they both equal the same thing, then they must equal each other. So we can conclude then that angle 3 equals angle 2, or I should say congruent to angle 2. And the reason we know that to be true, this little substitution that went on, is because of another axiom. And we have an axiom that says that things equal to the same thing, so things, meaning the angle 3 and the angle 2, these are the things, equal to the same thing, they're both equal to 180 minus angle 1, these things are equal to each other. So we finally finished the first part of our proof. That was the longest part, and that was because we used axioms and well, we didn't use the postulate yet, but we used our axioms instead of just using the theorem that vertical angles are congruent. We actually went and rigorously proved that they are. So now that we know that angle 3 is congruent to angle 2, we can go to the second part of our plan, which says then by the postulate that corresponding angles are congruent, angle 2 is congruent to angle 6. So angle 2 is congruent to angle 6 by the postulate that corresponding angles are congruent. And they are both corresponding, if you recall, they're both above and to the right of the transversal. Above and to the right of the transversal. So now we're almost done. We have 3 equaling 2, we have 2 equaling 6. So you got it. Now we can conclude that angle 3 must equal angle 6. And that is by the axiom, again, that things equal to the same thing. So things, meaning, angle 3 and angle 6 are both equal to the same thing. So then those things must be equal. They are equal to each other. So there you have it. We have proven that alternate interior angles are congruent.